Hi. Right, so I thought I'd help you out with the homework and look at just question 3. The first 3 parts are really just basic skills as far as the vector is concerned. It tells you that these 2 lines intersect with the point A. You've got an unknown here, so to find out where they do meet, you'll have to use the I component and the K component, not the J one. And once you've done that and you've found your S and your value for T, then you can put the J components equal to each other and you can work out what the value of A is. Using back to the point A, you can stick your T into L1 or the S into L2. And the acute angle, remember, it's the angle between 2 vectors, use the directional ones. And that's, like I say, it's basic skills we're using there. Now I want to show you the last part though. It says point B lies in L1, point C lies in L2. So we'll draw L1 and L2. This is me using my new pen here. So this is L1 and this is L2. I'm going to write next to L1. That's the T equation, and this one is the S, and the point of intersection is A. Now you'll notice my writing's pretty rubbish, but I'm practicing. It's actually even worse than my normal handwriting, which is bad anyway. So I know they intersect at the point A, and B lies on L1, B lies on L1, and C lies on L2. C lies on L2. I'm trying to try and do button. B lies on C lies on L2. Right. The triangle ABC is equilateral. Well, we know this angle is 60 degrees, and the sides of length 14√2. So I need both of that line from A to B and the length from A to C is 14√2. Find one of the possible position vectors for B and the corresponding position vector for the point C. Now you worked out when you find out what A was, you worked out what the value of T was and the value of S was at A. Now to go from A to B, we need to do a certain number of the directional vectors for L1. So L1 is the T1. So the length of this vector, if you work out the length of this vector, it might get 14√2. 14√2 as the length of the directional vector, which means that there should be one directional vector in there. It might be that you get 7√2, in which case you'd need 2 directional vectors in there. Now, if, for argument's sake, the T was 1 here, and the length of this line, as I say, is 14√2, and the directional vectors are 7√2, and you need 2 directional in there. Just here, the T value will be 2 more. It might be that the directional vector is just √2, so we need 14 of the directional vectors in there. So there, the T will be 15. You do the same thing with the C, work out the length of the directional vector, find out how many you need to fit in there, and whatever value of S you got here, you add that number of directional vectors on, and that will give you the S value at C as well. I think that's about that should just about get you there, I hope. So tune in next week for more exciting videos.